This is a continuation of the Programming Review Units 4 and 5 in AP Computer Science Principles. In this one, we will talk about procedures, functions, methods. They're all the same thing, just different programming languages have different titles for them. Essentially, you need to understand that procedural abstraction allows us to provide a name to a process, and then allow us to a process, then perform that process without necessarily knowing how it works, but just by knowing what it does. Like driving a car. I know getting in the car, turning on the ignition, putting it in drive, pressing the gas, pressing the brake, and moving the steering wheel will allow me to drive the car. I do not have to have any kind of intimate knowledge of the internal combustion engine, the transmission, the drive shaft, any of that. So procedural abstraction allows us to name a process and then use that name to do that process without understanding the details. A procedure is a named collection of steps in an algorithm that can be reused anytime it is needed. A procedure is an abstraction because the details of how it is performed are only defined once, and then its repeated use of the procedure ignores those details. If I actually even write the code, I only have to write it once, and then I don't have to worry about how I wrote it. It's done and it works once it's been tested. Procedures are examples of abstraction in programming. Procedures do not make a program more efficient, does not make them run faster, but it can improve code readability, it can manage the complexity, and it can allow programmers to change the internals of the procedure without needing to notify users of the change, as long as what the procedure does is preserved. Depending on the programming language being used, a procedure may be referred to by different names, such as method or function. Take a simple procedure example, modeling conversation. I have had multiple times with my toddler. Note that this is AP CSP pseudocode. So procedure, refuse. Display, no mommy. Display, I do not want to. So here, display, can you put on your shoes? Then we call refuse. And the toddler says, no, mommy, I do not want to. Then I say, can you put on your jacket? And then I call refuse. And refuse says, no, mommy, I do not want to. Then I say, can you put on your hat? And we call refuse. And the toddler says, no, mommy, I do not want to. This is an example of a procedure that accepts no parameters, meaning there's nothing in the parentheses. Don't pass it any information. It just runs. Procedures will only run their code when they are called. Procedures defines procedure name as a procedure that takes 0 or more arguments. The procedure contains a block of statements. The procedure, proc name, or procedure name, can be called using the following notation, where arg1 is assigned to parameter 1, arg2 is assigned to parameter 2, etc. So I could call something proc name and pass it some information. This information is passed literally in order. So arg1 gets placed into parameter 1. arg2 goes to parameter 2. And then these are used within this block of statements. Procedures with return values. Sometimes we want something to return. Think about when you use the square root button on your calculator. That's a function or a procedure that's built into your calculator. Proc name is a procedure that takes 0 or more arguments, contains a block of statements, and then when it's all done, it returns some value. The return statement may appear at any point inside the procedure and causes an immediate end of the procedure and a return back to the calling statement. The value returned by the procedure can be assigned to the variable resulting in the following notation. Result is set to proc name, arg1, arg2, etc. So if this were, say, an area program, result could be set to calculate area, length, width. Goes down, gets the length, the width, multiplies them together, and returns. Let's look at some examples. Define area of a rectangle. And I'm going to accept length and width as parameters. It's going to calculate the area as length times width, and then it's going to return the area. Here in the main program, okay, this is separate. The main program, W is set to input what is the width of your rectangle. Length is set to what is the length of your rectangle. So the user types those in. You get W and L. Result is set to area rectangle LW. I pass it the length, I pass it the width, it figures it out and sends it back, and we store it in result, and then result is printed. So here's an example. What is the width? I put in 5. What is the length? Put in 4. It calculates 5 times 4. 5 times 4 is put into area, return area. Area gets returned here, stored in result, and the result is printed. Here we have check answer, and we pass answer. If answer is less than 0, we're going to return negative, else return positive. So my input, please enter a number. And then we're going to print check answer my input. So up here, if I enter a 2, 2 comes in here. We call check answer, pass it the 2. 2 is answer, so 2 is less than 0, no, so I'm going to return positive. On the other hand, what if it was negative 5? Then, right here, I input negative 5. It calls check answer. The negative 5 goes to answer. Answer is negative 5. Negative 5 is less than 0, so I'm going to return negative, and I'm going to print negative. A lot of handing back and forth of information. Look at this. We've got Old MacDonald. We have a refrain. What is refrain? Old MacDonald had a farm, E-I-E-I-O. Sing, animal, cow, moo. So I sing. Where is sing? Here's sing animal. We have cow, we have moo. And on his farm he had a cow, E-I-E-I-O, with a sound, which is moo, moo here, and a moo, moo there. Here a moo, there a moo. Everywhere a moo, moo. And then it comes back up here, and what do? We go to the refrain. Old MacDonald had a farm. Notice, we can write 3 versions of Old MacDonald in the same amount of space that it takes to basically write one. Whoops, did not mean to do that. I want to do this. Boop. So here's the first one with cow. If we send it with pig, the name is pig, the sound is oink. And on his farm he had a, what is name? Pig, E-I-E-I-O, with a oink, oink here, and a oink, oink there. Here a oink, there a oink, everywhere an oink, oink. And it keeps on going. Pause the video. Make sure that you understand what gets called where. This code is your main program. These are 2 procedures that are being called. Here we have x gets 10 mod 3, y gets x plus 5, z gets y minus x. Answer gets the average of these 3. So we have x, we have y, and we have z. 10 mod 3, the remainder is 1. Y gets 1 plus 5, which is 6. 6 minus 1 is 5. Now, display the average. Well, how do I do that? 1 goes, A becomes 1, B becomes 6, C becomes 5. I get 1 plus 6 plus 5 is 12, divided by 3 is 4. So I'm going to store 4 here. So then I'm going to return 4 up here, to here, which then is going to store it in answer, and then we're going to display the answer, which will display 4. Parameters allow the creation of a generalized solution to a whole class of problems, rather than individually solving many specific problems. Parameters remove the need to create repetitive functions, making code easier to write. I calculate the area the same way no matter what. I just need to know length and width, and then I can multiply them together. Whenever you have 2 functions that basically do the same thing, make a function with a parameter instead to remove the need to duplicate the code. If you do need a function to do the same thing a lot of different ways, then use a parameter so one function can do it right away. And if you find you've got a mistake, you only have to fix it in one place. And if you make modifications, again, modifications in one place. Now, After this one, you'll be reviewing lists.